Right, so I'm going to talk about scaling Puppet workflows and a bit about, how our infrastructure looks like and where we're coming from with Puppet and how we're currently doing things, but also a little bit outlook into the future, how things we're planning to do to scale the workflows even better. A little bit about Spotify. You probably know what we're about already, but we're a music streaming service that have over 24 million active users. We're launched in 55 countries and have more than 1.5 billion playlists, 20 million songs. And all these numbers are growing very quickly. And just a few years ago, we had 0 users and only a dozen employees or so, and now we're more than 1,000 employees. And Puppet has been a great tool and very important tool for us to scale our infrastructure so quickly. So who am I? As the first slide said, I'm Dalen on IRC, and I'm a Puppet community contributor, made a lot of contributions into Puppet itself, but also some tools around it. And earlier, some of you used them, for example, the so-called crazy Puppet DB hire backend. But I'm also working as a system engineer at Spotify within our infrastructure and operations part. I'm in the team that is mostly handling configuration management and automation and those sorts of things. So a little bit about our Puppet infrastructure. We have 3 different Puppet setups actually. So there's one for the production environment, one for our testing and development environment. It's sort of a big environment used it for both. And also one for our laptops and workstations. And they all have a separate Puppet DB instance. They all have their own CA and so on. The testing environment and the production environment setup shares the same Puppet code base, so it's all the same manifests and modules and that, but the one for laptops and desktops have a completely separate Puppet code base, because there might be some things about the networking configurations that could be shared, but there's very little, to be honest, to share between the laptops and servers. We have 4 different data centers. Some of them have quite a lot of nodes, so they're kind of subdivided into what we call pods, around 500 to 1,000 machines in each pod. We run one or more Puppet Master for each of these pods. We found that, it depends a little bit on how many resources you're managing, but one Puppet Master can scale to between 500 and 2,000 nodes maybe. In our case, it's probably on the lower end of that scale. We're running Puppet from using cron every 30 minutes, so we don't have the kind of long-running agent running all the time. We're using some tweaks to the Apache config to do some optimizations, for example, caching of file metadata requests and some tweaks with the SSL certificate serving and so on. But in general, it's a fairly standard like Apache and passenger setup. This is a screenshot from Puppet's the dashboard in Puppet DB from one of those installations. There's quite a lot of resources that Puppet is managing. A little bit about the Spotify architecture in general. most of our services are built as stateless services that have a storage backend, which is in most cases Cassandra, but for some services we're using Postgres. Some of them also serve fairly static data, so we're using like Sparky, which is a project we've done where you can have like indexes on disk and look up values very, very quickly. So for example, search indices and that sort of things are just stored on the service machines themselves and distributed like daily or hourly and so on. The clients connect through an access point that basically authenticates the client and works as a kind of proxy to all the other backend services. And then once it's authenticated, it can send messages and contact all the different backend services. And the access point handles like figuring out if nodes have a high error rate or if they go down and so on. And that's kind of service discovery, so it knows which backend node to send each request to. And this is a little bit simplified picture. I mean, we have a lot of services contacting each other. Sometimes this is also across different data centers. But in general, most of these services are developed by different teams. And we have quite a lot of them, probably, I mean, more than 200 different services that run in the backend. So each team is responsible for writing their own Puppet manifests to deploy these services, to test them out in the testing environment, and so on. And I mean, it's too many services and too much infrastructure for like an operations team to keep track of all of it. So we've had to scale the workflows a bit. We've been using Puppet for 3.5 years, roughly now. Before we used Puppet, we were using a tool called AI. It's a kind of automated installation system for Debian nodes, specifically, or mostly, but that uses like shell scripts to set up nodes, and it can also update the configuration a little bit, but it's kind of clunky to use, and the experience of most people was that you kind of did updates and then you crossed your fingers and hoped that things didn't blow up spectacularly. There's no way to really test the changes and no modes and that sort of things. Back when we started deploying Puppet, I mean, we started small. We puppetized one of our things. We didn't start with like everything at once, so we started with a sort of non-critical component, which was the monitoring system, and which back then was Zabbix, switched now, but after then that moved on to puppetizing Puppet itself, and I mean after then it just sort of spread to more and more things gradually. In the beginning, it was only a couple of people, mostly within the operations team, doing a lot of the Puppet code, but as this sort of graph shows it has grown pretty quickly, and now we have almost 300 different people within Spotify that has committed the code to our Puppet repository. And I mean, pretty much every configuration for every backend service is publicized now. So a little bit about our Git setup. We're using Gerrit for code review. Moment we started using that after about a year after we started using Puppet. But yeah, I mean, there's been a lot of presentations about Git and presentations and so on, so I'm not going to go into all the details about that. But we have the repository is using SSH push replication from Gerrit, so as soon as you change to Gerrit, it's replicated out to all the Puppet masters, and they have an update route that checks each Git branch into a separate directory, and that's mapped to a Puppet environment. And these Git branches, I mean, we have so we have every node is running on the production branch in Git, and to push to that you need to have a code review. You can't push to it directly, but to any other branch, any developer can push code, and you can run Puppet against that branch or that Puppet environment that it's mapped to. So sometimes I mean, this is used a lot for like testing your Puppet code before you push it out for code review. But sometimes we also kind of abuse it for things like canary deploys or gradual rollouts, that you can sort of gradually switch machines to use a different Puppet environment or Git branch them. And then once you roll it out to all the nodes in the cluster, you can merge it to the production branch and switch all of them back to use the production branch. Which is, I mean, maybe not the optimal setup to use that for that, but it works. So we have a wrapper script around Puppet, well, SP Puppet. Most of our tools start with SP, that's in Spotify. And that can be used to kind of get some status about what Git branch a machine is running on. You can change the Git branch it should run Puppet against. You can do individual runs against a specific Git branch. And it does the whole kind of name mangling thing, like because in Git branches you can have slashes, for example, that aren't an allowed character in Puppet environments. So it just translates all those characters to underscores. So it works. So, I mean, in most cases we have like username and branch name, or username / branch name. It can also be used for disabling Puppet runs. So, for example, if things are shit hits the fan and you need to do something manually, you might want to kind of stop a service and you don't want a Puppet run in the middle of it to start it again and that sort of things. When you're in the middle of debugging something, you can just temporarily disable all Puppet runs and start and stop services and those sorts of things. As I said, we use Gerrit for code review, and up until around 6 months ago, we had our SRE team, which is the operations for the production environment, do all the code reviews. So developers could push to any feature branch, they could run Puppet against those feature branches, test their changes, and so on. But for the change to go into the production branch, it had to be reviewed by someone from the operations team. And this was a big bottleneck and became bigger and bigger as time passed by. So we had to do something, and I mean, it led to a very long kind of lead time. I mean, people had to wait sometimes 2 or even 3 weeks to get their changes reviewed by someone in operations, and we weren't happy about that. So we wanted to do some testing automation. I mean, even before we did like Puppet link tests, syntax testing, and those sorts of things, but no real testing of the Puppet code per se, except like manual runs against those feature branches. I mean, we wanted to let anyone do code reviews and merge changes into the production branch. But we wanted some sort of sanity checking of those changes, so we didn't get any big oops that screwed up every node on in the whole fleet. We started using RSpec system, RSpec system Puppet, which is an open source project mainly made by Ken Barber, which is Puppet Labs guy. It's called some PuppetDB. So for each review, it spins up a node in AWS. It applies all the Puppet manifests on it, checks that it all applied without any errors. It applies them again and checks that it doesn't do any further changes the second time you run Puppet. And then it does some sort of basic sanity checks of the host. Checks that SSH daemon is up and running. It checks that it can resolve things, so you haven't screwed up result.conf on every host, or something like that. It checks that if you create a user, you can SSH in as that user afterwards. And a lot of pretty basic, really tests like this. So at the moment, it only checks our base module that is installed on every host or used on every host. It doesn't do any testing of the application-specific modules. So for that, I mean, that's definitely something we want to do, hopefully sooner rather than later, but we haven't gotten there yet. And then we have some Prolog merge rules, as was mentioned in one of the previous presentations. And Prolog is a logic programming language, so it's probably very well suited for hotpens. And yeah, we wanted a bit of a custom rule set here of when you could merge changes and so on into the production branch. If someone wants a copy of these rules, just ping me on IRC and I'm happy to send them to you. So basically we wanted so that anyone could do a +1 on a change. The SRE team can do a +2 on a change, and they can actually merge a change even if the tests fail. So if you wake up in the middle of the night when you're on call and things are broken, you don't really need to wait 10 minutes to get back a test result before you can merge your change. And if you did a lint error, you can merge it anyway. I mean, you can fix that later during office hours in that case. But for the normal kind of workflow, we wanted so that people could do a +1 on the reviews. If 2 people had done a +1 and they also passed the tests, then anyone could just hit merge on that. So, and I mean, we've solved most of the issues through policy instead of enforcing hard rules on who can review in what module and so on. We just tell people that, yeah, you should assign reviewers that actually knows anything about the module that you made a change in. The ones that are sort of responsible for that system might want to review it instead of just the person that happens to sit next to you or so. But in general, a lot of the changes are teams that develop one of their services and they want to make a config change in their own service, so they have someone else in the same team review their change instead of having some operations guy that might not even know really much about that system at all. But sure, if they want to make a change to the sort of baseline configuration that's going to apply to all the hosts, they should assign someone in operations to take a look at the change. But we solved that through policy instead of actual hard rules, and it's worked pretty well. So the current state of our Puppet workflow and so on, we push out roughly 30 changes every workday to production. I mean, that's only counting non-merge commits, so it's actually changes. So yeah, roughly 700 a month. We have 430 different Puppet modules, so as you can imagine, that's a bit too much for like one person to keep track of what all of them are doing and so on. I mean, that number has probably increased by like 100 modules in the last 6 months, and I don't know what's half of them. And this graph shows the number of commits per user in the last 12 months. So as you can see, I mean, there are a core team kind of that are doing a lot of the commits. A lot of them are what you could consider like operations people. I think the top 6 of them are sort of operations people, but then you actually have like developers on the 7th place, and there's a lot of backend developers that have like 50 commits per year into the Puppet manifest. And yeah, we're very happy we don't have to do all these changes for them or something like that. I mean, it would have been very tedious if they had to create like a Jira ticket and have operations do the change for them. So, and then there's a lot of people that have only done like 1 or 2 commits in the last year. So a little bit about some of the sort of things we're doing at the moment and where we're heading. So we're at the moment working on using Puppet masterless, which we also call Ronin, which is the masterless samurais in Japan. And this is not so much about like scalability, like technical scalability issues with Puppet. I mean, it can scale pretty horizontally. You can, I mean, fairly easily provision new Puppet masters and so on. And yeah, that's not really a big issue for us. But in terms of workflow, we think that running things masterless will be an improvement for us. This is some of the reasons here. I mean, for example, there's a lot of logging that is done during the compilation process that is only visible in the logs on the Puppet masters. So for example, deprecation warnings, they're not really visible to our users of Puppet. I mean, we can see them in the master logs, but when people are developing Puppet modules, they can see if they're doing or using deprecated stuff. But with masterless, I mean, if you run Puppet apply, the compilation is done on the node itself, so you can see all the logging output from that. And if you run with -- verbose, you see deprecation warnings on the console. Also, you can see debug outputs. So if you run it with --debug, you can see debugging outputs from the compilation process. So for example, it will spit out a lot of debugging outputs. I mean, with the Hira lookups, we're using Hira, it will actually have a debug line saying like, I looked for this YAML file, but I didn't find it. Then I looked for this YAML file, I didn't find it either. Then I looked for this file, I found it, but I didn't find the specified key in it. And then I found this 4th YAML file and I found the key. So I'm using that key. So you can, I mean, people will be able to debug these sorts of issues. I mean, if they have some issues with the data bindings or Hira and they want to see why doesn't it find my key, I mean, they can get a little bit more information about that directly without having to like start a different Puppet master that's running in debug mode. So you can get debug logging from it and run an agent with like -- server equals debug Puppet master and so on. It also allows testing of changes without going through Gerrit. I mean, at the moment we have you have to, when you're testing the changes, they're all in like private branches. You have to commit the change, do a git push, then wait a little bit, a few seconds for Gerrit to replicate that change, and then you can run Puppet against it. I mean, with this you could actually like just rsync the manifests to the node in question and run Puppet. So it saves like a minute or something in each iteration of testing Puppet changes, which is something people have definitely been asking for. Also, things like functions and types, if you're developing those, you can debug why they are failing without having to go to the master side. And we think it will also allow us to use a bit more experimental features of Puppet more easily, like the future parser, for example. So we can enable that on certain hosts without enabling it on all hosts, and so on. Because at the moment, that's something you enable on the Puppet master. So all nodes using that Puppet master will get that feature. With masterless, you can enable it on the host itself. There can be some security considerations when using masterless. I mean, we're using Git mirrors, so it will replicate all the Git changes to like, Git mirrors and then fetch the manifests down to the nodes. If your manifests contain a lot of like secrets and database passwords and those sorts of things, they will be replicated down to all nodes. So if any single node gets compromised, it has like all the secrets, and that's not a great situation, of course. But you shouldn't embed database passwords into your Puppet manifest anyway. So we've created a small service called Poppy that a node can contact, authenticate using its Puppet SSL certificate, and then that service will send the secrets that that node should have. It's basically a hierarchy that it sends as a tarball, and it's only the parts of the hierarchy that applies to that node. So, I mean, all nodes will get the secrets in common.yaml, which shouldn't really contain any secrets, but I mean, you can have secrets that are only for one role of hosts, and only hosts with a certificate matching that role will actually have access to those secrets then. There's also some security considerations with Puppet DB. We're still using Puppet DB even with masterless. I mean, it stores a wealth of information about neural nodes, so, and some of that might also contain sensitive information. At the moment, it has very coarse-grained access controls, so it has an option to have a whitelist, and then you can have a whitelist of certificates that can access it, but they can access everything in it, and the other certificates can't access anything in it then. And we wanted something a little bit more fine-grained than that. So we created a filtering reverse proxy using Apache, the JSON query tool, and modxfilter. It will only expose resources that are marked as exported resources. So on all other resources, it will hide the parameter, or all the parameters for that resource. So if you have like a file resource that has content parameter, for example, you won't be able to see the content in the results from Puppet DB unless it's an exported resource. Also, all nodes are only allowed to send commands for themselves, so they can't send like facts or catalog for some entirely different node. It checks that the certificates that they authenticated with and the node that they're sending commands for are the same. Yeah, this Apache proxy, I have it on a gist on GitHub, but also if you can go in IRC, I can send it to you. I mean, it might not be that useful if you're not using Puppet masterless, but it can also be useful, for example, if you want to expose like Puppet DB to your internal network or like to your office network without having to use like the Puppet SSL certificates to authenticate against Puppet DB. I mean, you could expose all the contents but hide, for example, parameters or disable sending commands and so on. I mean, it's just a small tweak to the Apache config to do that. Another thing we're planning to do quite soon is to split our Git repository. At the moment, we have just one giant Git repository that contains the higher data and all the modules and so on. This has some pros, but also some cons. As one mentioned earlier, I mean, you can't have any really fine-grained access control. We don't have a big need for that though, on the other end. But it's also, I mean, kind of simple to use. It's when you create a feature branch, it's just a feature branch for all the modules and so on. You can do feature branches of the higher data, and it's no different than feature branches of the modules. You sort of know what's going to be applied to the nodes. I mean, it's what's in that Git tree. And you can do Git reps across all the modules and so on. But, I mean, it ties together a lot of pieces that should be kind of independent pieces. And it's also a little bit hard to work with upstream modules. I mean, at the moment we just sort of copy them down and commit them into our big giant repo. And it's not the best workflow for tracking upstream. One nice thing about it though is that when you make a backwards incompatible change to a shared module, for example, like the Apache module, you can in the same commit adjust all your other modules that are using the Apache module to kind of cope with this backwards incompatible change. When they're all in different Git repos and so on, that becomes a lot trickier. We've started creating a tool that's a bit of a proof of concept at this stage. It's called Spycore, named after this He-Man character. Also because it starts on SP, like all the Spotify tools. It consists of an implementation of the Puppet Forge that has some special features, like it can fall back to other forges if you can find the module inside that forge. Because the Puppet module tool can only have one forge that it contacts. We'll see, we might end up just fixing that issue in the Puppet module tool itself instead of having it sort of fixed in the backend. But at the moment it fixes it in the backend. So then you can have like all your modules in the production branch forge and create a new forge for each feature branch. And you could upload only a single module into this feature branch forge. So for when you then run Puppet against that branch, it would use that module from the feature branch forge. But for all modules it can find there, which should be all other modules, it would revert to the production branch forge and download modules from there instead. And I mean, the Forge also has a nice, I mean, it's a fairly standard thing in Puppet otherwise. We've considered also packaging them as Debian packages or things like that, but it's kind of nice to just use the standard tooling for Puppet. Then this tool also consists of a node terminus. So the current version is made for using Puppet masters and Puppet agents. So it has a node terminus that can dynamically on each compilation request, it will create a new node-specific environment. It will look then in Hira what modules should be installed for this node, and then just install them into this node-specific environment. And it uses the Puppet module tool to resolve dependencies and so on. And then it checks with the actual node terminus that you have configured what classes should be applied and so on, and then does the compilation inside this node-specific environment. So this allows, for example, I mean, even if many nodes are running on the production environment, they can have different versions of the same module. And we looked a little bit about like using Git submodules and RTNK or Puppet Librarian or things like that. But one issue we found was that when, I mean, if you have a kind of production branch, then with RTNK you only have one version of each module on that production branch. So if you have an Apache module, there's one version of the Apache module on your production branch, and all nodes have to use that version. But with this system, I mean, one node could use our Spotify Apache module, and a different node could use the Puppet Labs Apache module. And that, yeah, I mean, it's a lot more flexible, and that's even if both of them are running on the same Puppet environment. Because, as I said earlier, we have like 430 modules. I mean, sure, you can solve this sort of problem by like creating new Puppet environments that have different sets of modules, but the amount of permutations with 430 modules, if you want to support like multiple major versions of them, and you want to support, for example, other variations of the same module, like the Puppet Labs Apache and our own Apache module, and Puppet Labs Postgres and our own Postgres module. I mean, it becomes pretty ridiculous amount of permutations that you would have to like manually sort of manage and create Puppet environments for. So that's why this tool just dynamically creates one for that node on demand. It's available on GitHub. We haven't put it into production yet, so at the moment it's a bit more of a kind of proof of concept code. It works. It's been tested with production machines even, but yeah, it's not entirely put in production. As we're moving to using masterless, we'll probably incorporate this into the Ronin tool. Because, I mean, you can create node-specific environments on the Puppet Master, but to be honest, in the end, it's kind of easier to do it on the nodes themselves if you want to do node-specific stuff. But it's doable with both. All right, questions?
I have a question. Well, it's very impressive how the scale you achieve, how you nodes and stuff, and how you're all managing that. But I can imagine that you ran into some obstacles along the way, and so starting off in the startup right now and thinking about scaling in a later stage. We would love to hear about your experiences with, well, for example, outsourcing, cloud hosting and stuff like that, or what plays well with Puppet and whatnot. Can you tell us, share some ideas?
Yeah, the question was a bit about scaling like infrastructure and cloud hosting and what plays well with Puppet and not. I mean, in general, we run most of our systems on hardware that we own. The testing environment is running in AWS at the moment. So we're probably planning on running even some production hosts on the AWS and so on. But in general, it's not much of a difference for Puppet with like running on physical hardware or in the cloud providers or so on. It's pretty much the same to Puppet. I mean, one scaling issue with Puppet might be that you probably, if you have multiple data centers and so on, you would want to have local Puppet masters in them. The current Puppet protocol is pretty chatty. I mean, it does like compilation requests, and then when it gets the catalog back, it for each file resource that has a source parameter, it will do another request to the Puppet master and ask like, what's the checksum of this file resource? And then it will compare that to the local checksum, and if they differ, it will do another request to the Puppet master saying like, yeah, can I get that file? I actually needed it. So, I mean, if you have like 500 file resources, that can amount up to like 1,000 queries to the Puppet master on a Puppet run. So, and if that's like 1,000 queries across the Atlantic, it will be a very slow Puppet run. So you definitely want a site local Puppet master and so on. Yeah, if you have further questions, maybe we can take them afterwards. Well, I mean, I could probably go on for a while about scaling our infrastructure.
Yeah. We also use Puppet to deploy applications, not only the system, but also the applications. Because we have so much experience to advertise not only the system, but also the services and the code in the product that we help.
Yeah, the question was if we use Puppet also to deploy applications, and yeah, we do that. So at the moment, all our internally developed applications are packaged as Debian packages, just like regular Debian packages. So we have an internal Debian mirror for all our packages, and I mean we deploy them using Puppet just like any other Debian package, really, just with like the package resource and so on. So yeah, I mean, from Puppet's point of view, they just look like any other application. And I mean, there's definitely some work involved in like doing all that Debian packaging, but it also has a lot of benefits. Yeah, you can upgrade applications and the OS and so on with the same tool.
Developers and the DevOps all use Puppet to deploy everything.
So both them and ops use Puppet. Yeah.
Do you also have Windows machines on top of
No, I mean, yes and no. In the production environment, we don't. No, we don't have any servers running Windows at all. We use Puppet also for laptops and workstations, and there we have a bunch of Windows machines. So we have like Puppet modules for deploying Office and that sort of things, and like doing printer settings and network authentication settings and all these kinds of things. So yeah, we in one sense we use it on Windows definitely. Yeah.
If you have a busy day and you scale 100 extra machines, are they deployed automatically, or are the machines already ready in an off day? And if they are deployed automatically, what is the way to automatically deploy?
The question was about how we trigger deploying of new machines, and if we want to deploy a lot of extra machines, how we do that. So we also have a kind of inventory system that tracks all the hardware, and we have some tools around that to sort of trigger machines to turn off on and off, and do pixie boots and so on. So it's using cobbler for pixie booting the machine, and then we'll do you have a tool that you say, I want to install a bunch of machines with this role in this data center. They should have this hardware type, and it finds machines of that hardware type in the data center that are marked as available, and they're turned off then and don't have any OS, or have some OS left over from some previous use case they had. And then they're pixie booted using cobbler. They run a regular Debian installer basically, which also installs Puppet. And I mean, after the base Debian install is done, then Puppet takes over. And depending on the role of the host, it does different things. I mean, we don't have any ENC actually, and we don't have any node statements inside PP. We just use hierarch to classify nodes and tell them what classes they should have. And at the moment, the role of the machine is encoded in the hostname. So there's a custom fact and a hierarchy for the role of the machine. That's one. That's one.
I have a very simple question, maybe a stupid question, I don't know. You mentioned that it was impossible to have a Puppet Forge Apache model and your own Apache model at the same time. Wouldn't it be very easy to make a differently named copy of the model and use your own changes on it?
So the question was if you could have like different versions of modules at the same time, if you just like name them differently. And yeah, it is possible, but it's also, I mean, the Puppet autoloader will look for classes named certain ways in certain directories. So if you rename the directory, it won't really find them. So then you need to like rename the classes and the defined types themselves as well, and like of course then change any other module that references those classes and defined types. So I mean, it would be possible to have like two Apache modules side by side with different names, but you would need to refactor a lot of code to do it. So yeah, it wouldn't be an automatic process.